Good morning, class. In our last class, we have seen the topics chemical reactions of aldehyde and ketones, and in this, we studied about reaction with HCN. Then we studied about reaction with sodium bisulfite. Then we have seen reaction with Grignard reagent, and after that, we have seen reaction with ammonia and its derivative. So this is our last topic. Now, today we are going to see the other chemical reactions of aldehyde and ketones. Say for example oxidation. In this we'll see about haloform reaction, Tollens'test, Fehling's test. After that we'll see reduction to alcohols and then reduction to alkanes, and mainly about the two important naming reaction, Clemenson's reduction and Wolff Kishner reduction. Okay. Now first we'll see the oxidation method. What will happen when aldehyde and ketones are oxidized? Aldehyde gets easily oxidized to carboxylic acids by HNO3, KMNO4, K2Cr2O7. All these are oxidizing agent, or even by mild oxidizing agent. So if you have got an aldehyde and when you carried out oxidized method by the oxidizing agent, it will convert into acid form. Ketones are generally oxidized under vigorous condition, that is strong oxidizing agent and at elevated temperature. So if you take over here, say for example acetaldehyde, it will give you acetic acid. That means the aldehyde oxidized to give the acid with the same number of carbon atom. Whereas in case of ketones, if you take this as ketones, then what will happen? There might be a mixture of two acids. Say for example, if the bond breaks between this carbon number 1 and 2 over here, so from this part you'll get one acid and from this part you'll get another acid. Or if the bond breaks between these two, from this you'll get one acid and from this you'll get another acid. So from aldehydes we'll get the acid with the same number of carbon atom, but from ketones we'll get the acid with the least number of carbon atoms. Now next, a very important, okay, this you can rate it as 5-star, Tollens'test. This we are going to perform this test in the practical as well. Now let us see what is this Tollens'test. Tollens'test is used to identify aldehyde compounds. So for this, what we'll do is we'll take the sample aldehyde and we'll add Tollens reagent, which is ammoniacal silver nitrate solution, and after that we'll keep it for hot water bath. That means we'll keep the test tube containing the sample and the Tollens reagent in the beaker containing the water and keep it for warming. After 4 to 5 minutes, you'll observe that the outside of the test tube is covered with the silver color, and that we called it as also called as silver mirror test. So on warming an aldehyde with freshly prepared ammoniacal silver nitrate solution, this Tollens reagent, a bright silver mirror is produced due to the formation of silver metal. The aldehydes are oxidized to corresponding carboxylate anion. The reaction occurs in alkaline medium. So we have taken aldehyde, this is Tollens reagent, and this is alkaline. So it will form the carboxylate ion, or we can say acid, plus silver is formed. The formation of this silver, you can see the deposition on the inner side of the test tube, plus water plus ammonia. This is known as Tollens test. We have got another type of test which is also very important, Fehling's test. This test is also used for the test for aldehydes. So in this, what will happen? Fehling test involves the reagent Fehling solution, or we call Fehling's reagent, which comprises of two solutions, Fehling solution A and Fehling solution B. Fehling solution A is aqueous copper sulphate solution, and Fehling solution B is alkaline sodium potassium tartarate, or we call Rochelle salt. Now, This Fehling solution A and Fehling solution B are mixed in equal amount. Say for example, we can mix in 50-50 ml of both. That will be known as Fehling solution. Now, this Fehling solution, on heating an aldehyde with Fehling's reagent or reddish brown precipitate is obtained, aldehydes are oxidized to corresponding carboxylate anion. Aromatic aldehydes do not respond to this state. So what will happen? You take the sample aldehyde, and to that you add Fehling's reagent, which is a mixture of Fehling solution A and Fehling solution B, and keep it for once again a hot water bath. You'll find that after some time a red or reddish brown, or we can say a reddish brown precipitate is formed in the test tube. If it is formed, it confirms that the compound taker is aldehyde, and this is known as a Fehling's test. Whereas aromatic aldehydes, say for example benzaldehyde, do not respond to this test. So the chemical equation for this is, we have taken aldehyde, this we get from the Fehling solution, copper ions, and sodium hydroxide, which is a basic solution. This will form carboxylate anion. This will be a copper oxide. Formation of this copper oxide is reddish brown precipitate plus water. This is a Fehling solution test. Next, haloform reactions. So this reaction we have seen in the first chapter as well as in the second chapter, as well as haloform reaction, or we call iodoform test. So as we know that aldehyde and ketones having at least one methyl group linked to the carbonyl carbon atom, that is methylketo group. Aldehyde and ketones having a methylketo group, when treated with sodium hydroxide and iodine, it will form a corresponding carboxylic acids, and the iodoform is formed. This is known as haloform reaction. We have taken the ketone, and this NaOX, this has come from the reaction of iodine and sodium hydroxide. It will form sodium acetate and CHX3. If it is I, it will form iodoform. If it is Cl, it will form chloroform. This is known as haloform reaction. Next, reduction. What will happen if you reduce aldehyde and ketones? When aldehydes are reduced, it will form primary alcohol, and when ketones are reduced, they form secondary alcohols. So aldehyde and ketones are reduced to primary and secondary alcohols respectively by sodium boron hydride or lithium aluminium. These are the reducing agent. So when acetaldehyde is treated with lithium aluminium hydride, it will form primary alcohol with the same number of carbon atom. And when you take ketone, that is acetone, and if you reduce it with the help of lithium aluminium hydride or sodium boron hydride, it will form secondary alcohol. This is the reduction to alcohol. Next, we can also reduce aldehydes and ketones to alkanes compound. Okay, now the carbonyl group of aldehyde and ketones is reduced to CS2 group. Carbonyl group means C double bond O can be reduced to CS2 group on treatment with zinc amalgam and concentrates HCl, and this is known as Clemmensen reduction reaction. So when you take an aldehyde or ketone, and if you treat with zinc amalgam means Zn and Hg, in presence of constant HCl, it will form CS2. That will be known as Clemmensen reduction. Or with hydrogen followed by heating with sodium or potassium hydroxide in high boiling solvents such as ethylene glycol, it will form an alkene. This is known as Wolff Kishner reduction. So in Wolff Kishner reduction, what will happen? The aldehyde or ketone is treated with hydrogen. Hydrogen is NH2NH2. After that, we heat it with sodium or potassium hydroxide in presence of ethylene glycol to give you the product. We'll see the reaction for this. So the first one is Clemmensen reduction. So this can be aldehyde, CS3H if it is aldehyde. So when you treat with zinc amalgam and HCl, what will happen? This C double bond O will be reduced to CS2 group plus water. And if you take ketone also, CS3 over here and CS3, and if you treat with the same reagent, it will form CS3, CS2, CS3, that is alkane is formed, propane. Similarly, in Wolff-Kishner reduction, what will happen? If you take an aldehyde, CS3H over here, First we treat with hydrogen NH2. So what will happen in hydrogen? This will first remove a molecule of water H2NO and it will form this one, that is hydrazone. After this, when you treat with potassium hydroxide and ethylene glycol, what will happen? This C will reduce to CS2, other will remain as it is, okay? CS3, CS2H, and this NH2, another part will form nitrogen N2. This is known as Wolff Kishner reduction reaction. These two are very important reaction. Please mark it as important. Now today's assignment number 2, question number 1. What happens when acetaldehyde is oxidized with acidified K2Ci2O7? Question number 2, what is Tollens'test? Question number 3, what is Fehling's test? Question number 4, define haloform reaction. Question number 5, what happens when acetaldehyde is reduced with lithium aluminum hydride? And question number 6, give the balanced chemical equation for the following named reactions: Clemmensen reduction reaction and Wolff Kishner reduction reaction. So in this you specify the reagent used. Say for example, you can take acetaldehyde, and in this you can take ketone, that is acetone. Complete this assignment and send it in my mail.